Let's understand domain and range of a function. The domain of a function is the set of all possible input values, usually the x values. Let's find out the domain of a function. When the variable inside the square root is present in the numerator. We know you can never give a negative number to a square root. So set the expression inside the radical sign as greater than or equal to 0 and solve it. Find the domain of the following functions. Example 1. F of x equal to 2 times square root of x. Inside the square root is x, so x greater than or equal to 0 is the domain. Next, f of x equal to square root of x minus 2. Inside the square root is x minus 2. So x minus 2 greater than or equal to 0. Solving this inequality, we get x greater than or equal to 2, which is the domain of this function. Next, f of x equal to square root of x plus 3 plus 2. Here, inside the square root is x plus 3. So, x plus 3 greater than or equal to 0. Solving this inequality, we get x greater than or equal to negative 3, which is the domain of this function. Next, the range of a function is the set of all possible output values, usually the y values that the function can produce. F of x equal to 2 times square root of x. Here, x greater than or equal to 0 is the domain. So when x is 0, f will become 0. That will be the minimum value it can take. So as x increases, the value of f of x also increases. So f of x will be greater than or equal to 0 is the range of this function. Next, f of x equal to square root of x minus 2. When the whole expression square root of x minus 2 is equal to 0, so f will become 0. So that will be the minimum value of f of x. As x increases, square root of x minus 2 also increases. So we get greater than 0 values for f of x. So f of x will be greater than or equal to 0 is the range of this function. Next, f of x equal to square root of x plus 3 plus 2. So in this, when the expression square root of x plus 3 is equal to 0, so f will become 0 plus 2, which is 2. That will be the minimum value. So f of x will be greater than or equal to 2 is the range of this function. Next, let's find out the domain of a function when the square root is present in the denominator. Now we know that the expression inside the square root is greater than or equal to 0. But when it is in the denominator, it should not be 0 to avoid the division by 0. So set the expression inside the square root as greater than 0 and solve it to find the domain. Here f of x equal to 1 over 2 times square root of x. Inside the square root is x and it is in the denominator. So x is greater than 0 is the domain. And the range for all the values of x greater than 0, the expression gives a positive value and not 0. So the range is f of x greater than 0. Next, f of x equal to 1 over square root of x minus 2. Inside the square root is x minus 2, so set x minus 2 greater than 0. Solving this inequality, we get x greater than 2, which is the domain of this function. For all the values of x greater than 0, the expression 1 divided by some plus value, the positive value, gives a positive number. So the range is f of x greater than 0. Next, f of x equal to 1 divided by square root of x plus 3 plus 2. The denominator should be greater than 0. So when square root of x plus 3 becomes 0, still we get some value in the denominator which is greater than 0. So we can take square root of x plus 3 as greater than or equal to 0. That is, x plus 3 is greater than or equal to 0. Solving this inequality, we get x is greater than or equal to negative 3. So this is the domain of this function. Next, a range of this function, when square root of x plus 3 becomes 0 in the denominator, f of x equal to 1 over 2, which is 0.5. As the x value increases, square root of x plus 3 also increases, that is greater than 0. So when the denominator value increases, f of x decreases. 1 divided by some big positive number always gives some very small positive number, but not 0. So f of x will not reach 0 and it will always be greater than 0. So the range is 0 less than f of x less than or equal to 0.5.